Hello, welcome. And our topic here is going to be packet sniffing. So we're going to discuss what is the idea of packet sniffing, how to perform this type of task, and also how to detect one type of attack that is very much used when trying to packet sniff. So there are many tools available in order to perform packet sniffing. First, we have to understand what packet sniffing is about. Basically, it's just about capturing packets that are being transmitted through the network. However, nowadays, well, actually, for the past probably 20 years, just a simple packet sniffing is not a threatening task. And the reason for that is because most of the network devices that were started to be adopted in the past 20 years, the concentrators that companies started to use was the switches, network switches. Back in the day, companies used hubs, network hubs, as concentrators. Network hubs were devices similar to switches, but they would work in a broadcasting mode, meaning that every packet that would arrive in a hub, it would be dissipated, it would be broadcasted to all other devices that were connected to that hub device. So the problem about that is that let's say that you have a machine A sending a packet to machine B. All other machines, C, D, E, F, all other machines connected to that same hub would receive that same packet, that same information. Well, obviously, you can see a problem that we had there because simply by using a packet sniffing software such as Wireshark, devices, let's say C, D, E, would be able to also capture that packet and analyze that packet content. So let's say that you had a packet that was transmitting username and password. So the machines that were not supposed to get a hold of that information would be able to. Then companies started to use network switches. And network switches are a lot smarter, a lot more advanced than hubs. So if machine A connected to port 1 wants to send a packet to machine B connected to port 2, only machine B would receive that packet because the switch knows that packet has to be transmitted to port 2, in this case, in this scenario, should be transmitted to port 2 specifically. However, we still have a threat nowadays because after switches were widely adopted, hackers started to see that there was a need in order to be able to capture traffic. They would have to come up with a solution to be able to capture packets that were not destined to their machines or the machines that they were able to control. So what did they do? They created a type of attack called ARP spoofing. So ARP spoofing is a very simple attack where you scam the network devices involved in a communication, saying that you are one of the devices that is participating in that communication. So in the same scenario where we have host A transmitting to host B, and let's say that the attacker, the victim, is supposed to be host A. What a ARP spoofing attack would do is the attacker would tell the destination, would tell machine B that the attacker's machine is actually machine A. It would fake that IP address along with the MAC address. So the attacker would tell machine B, hey, whatever you receive from this IP address, where the IP address is the victim's IP address, you have to communicate with this MAC address. And then the attacker would associate the victim's IP address with the attacker's MAC address. Well, the destination machine, in this case machine B, would receive information from the victim, let's say from machine A, and would reply to the attacker, to the attacker's machine. The attacker's machine would receive that packet, get a hold of it, analyze it, and then would forward that packet to the original source, which is the victim's machine or the target machine. Well, since the target machine and the destination machine are communicating just as any other type of communication, the communication is actually happening. So they wouldn't know there's an attack going on. So the communication will just flow, will just continue. The problem is the hacker is actually getting a hold of that information that is being transmitted. So, as you know by now, nowadays, even with the adoption of network switches, it is possible to capture traffic that do not belong to the attacker or to other machines. So if there is a machine A transmitting to machine B, any other machine can actually get a hold of that information as long as you perform a ARP spoofing attack. Well, it's important to understand ARP spoofing because as I mentioned, most networks nowadays, they use switches. And in order to capture traffic using Wireshark, as we're going to see how to use, we have to first configure a ARP spoofing attack. But before we perform ARP spoofing, let's just do a very traditional analysis of the Wireshark software. So in Kali Linux, you can simply go to Applications, and you have here Sniffing and Spoofing, and here you have Wireshark. So I'm going to open it, and you have Wireshark for any operating system. So you have Wireshark for Windows as well. Okay, so here you can configure the interfaces that are going to be used in order to capture traffic. I am going to go here to Capture, Options. You have to make sure that the Enable Promiscuous mode on all interfaces is checked. You have here, in case you don't want to capture traffic on all interfaces, you can define here which interfaces you want to run the promiscuous mode. Now, nowadays, since we have ARP spoofing, it has to be used most of the times. It doesn't really make a difference whether you enable promiscuous mode or not, but the idea of promiscuous mode is allow your sniffing software to capture traffic even though those packets are not destined to your attacking machine. Okay, so I have this there. Then I can simply click here on Start. Well, and we're going to see some packets flowing here because these are packets that are always being transmitted in any working network. Specifically, the ARP or the ARP protocol, as we can see here, that is one type of protocol that is required in order to make layer 3 networks work. Okay, but let's take a look at specific packets. So let's see how to actually generate those packets so we can analyze them. Because as we can see, it keeps growing and growing. The number of packets that are being captured just keep growing. Okay, so here's what I'm going to do. I'm going to go to my terminal here, and I'm simply going to ping 8.8.8.8. And I'm going to interrupt it here and go back to Wireshark. Now, at this point, I'm going to stop the packet capturing right here. So to stop a packet capturing instance, you simply click here, Stop Capturing Packets. Okay, now, if I scroll up, I'm going to see right here and here. Let me see if there's more up there. No, so that's probably the first one. Okay, so let's take a look at this packet right here. There is a number, time, source, and source is the IP address that is actually originating that packet. That's the machine that is sending that packet. And this IP address here, 10.0.0.19, is my machine, my Kali Linux machine. And my machine is sending a packet to 8.8.8.8. The protocol, let me scroll this to the right. The protocol used here is ICMP. That's the protocol used by ping. Actually, ping is basically works with two different types of ICMP. ICMP echo request, that's when the machine is requesting a response right there. So my machine sent a ICMP echo request to 8.8.8.8, and then you may have additional information over there regarding the packet. So if we take a look down here, we can actually analyze each packet, each protocol according to the layers involved in that communication. So as you know, ICMP is a layer 3 protocol. Therefore, we have here Ethernet, our frame, which is our data link. Ethernet 2, that's our data link protocol. And then we have our Internet protocol, which is layer 3. And it's encapsulated, actually it encapsulates the ICMP messaging protocol, which is also a layer 3 protocol. So what is very interesting, and we have to understand and be able to analyze, are the headers or the headset, the fields that we have in each protocol header. For example, if we come here, I can click and expand, and I'm going to see some information, some lower layer information right here. Okay, so it's a Ethernet data link protocol. So I know that my link type is Ethernet. It's not, for example, Wi-Fi. It's not, let's say, ATM. Now, if I scroll down here, we have the headers of the Ethernet protocol. And in the Ethernet protocol, we have the MAC address, the source MAC address, the destination MAC address, which are the source physical address and that's destination MAC address. That's right here, source. That's my interface's MAC address. And this is the destination's MAC address. Well, actually, the destination MAC address is the concentrator MAC address, usually a switch. It's not Google's server's MAC address. So, we can see that it is this Ethernet protocol is actually encapsulating IPv4. Then we have our layer 3 protocol IPv4. It says that the source is 10.0.0.19 and the destination is 8.8.8.8. And here, once again, we can analyze the Internet Protocol header fields. If we want, we can expand it and we can detail each, we can see the details of each header field up here. And then we have the last protocol that is encapsulated by the Internet Protocol, which is ICMP. And there we can see that it's a echo request ICMP type 8, which is echo request. And that's our packet. Why is it so important to know how to analyze the headers? Well, it's important, first of all, because performance is very much related to the information that is carried in a protocol header. Second of all, many protocols, they transmit information that is critical, but they transmit that information in clear text. For example, we're going to take a look at the FTP protocol, FTP transmission, and we're going to see that FTP actually transmits passwords, usernames and passwords as clear text strings. Okay, now, this is a very simplistic way of using Wireshark or any other packet capturing tool. Now, if the information that we have here, and I'm scrolling here just so you can take a look at all the packets that were captured. And remember, this was in just a little bit over a minute of capturing. So here, second 0 to second 67. So in about 1 minute of capturing, we can see all these many packets here, about 90 packets. Now, imagine if you have to perform a live capturing, or if you had to leave the capturing software running for a very long period of time, and then you have to go there and analyze, search for specific packets. It's not going to be productive. Actually, it is totally unfeasible. So, any type of sniffing software such as Wireshark will allow you to filter packets according to several different types of information. For example, I'm going to go here in this field right here, apply a display filter. And this is where you can input your filters. Now, obviously, it is very difficult to know all the filters because Wireshark is not looking for any type of random strings. You have to know the filters or the filtering rules. So if you want to search for a specific protocol, you have to know how to filter for that, to apply a filter and find the packets that are using that protocol. If you want to find the communication between a specific source IP and a specific destination IP, you also have to know how to apply that type of filter. Well, to help you out, Wireshark has this button right here, expressions. So I'm going to click it here, and as you can see, and I'm going to scroll it down, as you can see, you have many possibilities to apply filters. Now, keep in mind that each of these filters here, they actually explode to more options. So you have many types of filters, and obviously you're not going to memorize this. However, you can perform a search. So let's say that I want to know how to search for a specific protocol. For example, ICMP. So it shows me all these different families of fields here. However, most likely what I'm looking for is this one, ICMP. And then you have some more specific filters for ICMP. For example, if you want to search for ICMP type echo request, you can perform that type of filter right there. ICMP type equals, let's say, 8. ICMP type 8. And I apply that filter. Enter right there. So 2 ICMP echo requests. Just remember, ICMP type 8 is the ICMP echo request, as we can see right here. What if I search for ICMP type 0? Oops. ICMP type 0. Okay, ICMP type 0 is the echo reply. So that's when the Google DNS server actually replied my ICMP echo request. And you can perform other types of filters here. So many options. For example, if you want to filter for a specific IP address, we could go back there to expressions. However, in this situation, it's a bit complicated because if I search for IP, well, way too many options, obviously. Okay, what if I want to search for source? Still too many options. So there are some situations where I have to know the filters that I'm looking for. And basically you can perform a Google search. Now, I can tell you that if you want to apply that type of filter, you can use ip.src equal. So ip.src is to specify the source. Okay, so the source is going to be my machine, which is this IP address here. What if I also want to search for packets where I want to see the destination as well? Oops. So there you go. You can use more than one filter using the AND keyword to put those two filters together. Okay. So now let's expand this type of analysis and let's perform a actual real capture. I'm gonna go here to my Windows machine. There. And let's say that in my Windows machine, let me go back to my Linux here, to my Kali Linux, and let me start a new capturing. So I don't want to save that. Okay, there it is. I'm gonna go to my Windows machine, and I'm gonna open the terminal here, and let's say that I'm going to, as a Windows client, that's a different machine, I am going to perform a FTP access. I'm going to access this random FTP server here. There it is. Okay. I'm gonna go back there. And let me stop the capturing here. Okay, let me scroll up looking for FTP protocol right here. Well, seems like there is no FTP. Okay, let me filter for FTP. Nope, nothing there. Now, why can't I see anything? Well, the reason why I can't see anything is, once again, because even though I'm running the packet sniffing in a promiscuous mode, the packet that is being sent out from the Windows machine to anywhere else is not going to be sent out to my Kali Linux machine as well. You can see some packets here that are from the Windows machine 10.0.0.179, but that's because they're destined to either a broadcast address or, for example, a ARP or ARP packet or a multicast information. Okay, which is the case of the 239. And we see here some information which is ARP that is being sent out to the broadcast address. Okay, so how can I force my Kali Linux machine to capture traffic that is not sent out to the Kali Linux machine itself? Once again, you simply have to perform the ARP spoofing attack. So what I'm going to do here is I am going to open a new terminal and just enter this command right here. The ARP spoof syntax is ARP spoof space -t space the target machine IP address space the destination machine IP address, which doesn't have to be the final destination. Actually, it is not going to be the final destination. It has to be the network concentrator, the network router. So in this network that I have here, 10.0.0.1 is my router, 10.0.0.179 is my target Windows machine. So I start running it. There. Now, what is it doing? It's ARP replying to 10.0.0.1 that this MAC address here is the one that has IP address 10.0.0.179. So it's scamming the router 10.0.0.1. Okay, now let's go back here and let's go back to Wireshark and run the capturing once again. Okay, there it is. I'm gonna go here to the Windows machine. And once again, I will try to FTP that random FTP server. Oh, I'm sorry. So let's start over. There it is. Guest user, guest pass. There. Now let's go back to the Kali Linux machine. Let me stop the capturing here. And let me scroll up, see if I can visually find the information that I'm looking for. And there it is. Now, it's going to be a lot easier if I simply filter for FTP. Now, I can see here 1, 2, 3, 4, 5 packets. 5 FTP packets. Let's take a look at them. So, this is the source, that's the destination, this is the source. This is the first time that I disconnected from that server and then I connected again from the Windows machine. So this is the connection request. Let's see if it is. I'm gonna scroll here to the right. There, it's a FTP transmission from my Windows machine to that destination machine, which is the ftp.localweb.com.br. The protocol is FTP. That's a file transmission attempt. And it's a connection establishment where I'm using the user, guest user. Then that server replies, that server replies to my machine another FTP packet, which is the response, with password required for a guest user. That's the message that has been sent to my machine. Then my machine will send, I respond with guest pass. That's the password that I tried. And the FTP server replied with user cannot log in. So this is a scenario where you can ARP spoof to capture traffic. Now, once again, you can always go down here and analyze those fields. So if we go straight to the layer 7 FTP header, we can see all the information that is carried by the FTP protocol. Well, the same thing can be done to other protocols as well. The difference is whether that protocol transmits clear text string or ciphered string. Okay, so that's how you can use ARP spoofing in order to capture traffic that is not sent to your machine. Now let's go back here to the Windows machine, and we saw that any network device is vulnerable for this type of attack. So let me quit over here, quit. So in any network, the ARP spoofing attack can occur. And there is one very important information here, which is firewalls are not capable of detecting this type of attack because they are not monitoring all the network devices, mostly because they don't know which IP address is associated with each MAC address. Back in the day, it was common to do this type of attachment. Say, this IP address here will always be associated with this MAC address here, or any type of physical address. It doesn't have to be MAC address. However, networks grew and enhanced so much that it's just unfeasible to perform that kind of association. So, firewalls are not capable of detecting ARP spoofing anymore. What can you do? The good thing is, the good information here is, there are ARP spoofing detection tools available to almost all operating systems. And it's not different for Windows. So, what you have to tell your client after you successfully perform packet sniffing in the client's network, you have to tell the client that they have to have any type of ARP spoofing detecting tool. For Windows, for example, there is a free tool called XARP. And this is the webpage, xarp.net. You can simply go there, scroll down, the link for the download is at the bottom. There it is. So for Windows and Linux, although it says Ubuntu, you can actually install in any Debian-like distribution. So now, once you have downloaded it, you can simply run XARP right here. Now, let me go back to my Kali Linux machine just for a moment. I am going to, okay, I can close Wireshark now. I am going to stop this ARP spoofing over here. Okay, now I'm gonna go back to my Windows machine and open XARP. Okay, so there is no secret. You just open it and it will try to detect ARP attacks or ARP spoofing attacks. Status, no ARP attacks. Okay, very good. It is sniffing my network, so it can detect that my network has all these devices. Okay, I'm gonna go back to my Kali Linux machine and just run my ARP spoofing command once again. I'll run it. Now I'm gonna go back to my Windows machine, and there it is. So now, status ARP attacks detected. This ARP attack involves 10.0.0.1, which is the router, 10.0.0.19, which is my Kali Linux machine, and 10.0.0.179, which is the Windows machine, and also 10.0.0.233, which is my VirtualBox system. Okay, so, and here on the right hand side, we can gather more information about that type of attack. But what is important here is that there are free softwares available, very easy to use, and all companies should have use one of these tools in order to detect ARP spoofing attacks, because they are so common, they are so easy to perform, and there is a very high probability that these attacks are actually occurring within a network. So in this lab class, we were able to see how to perform ARP spoofing in order to packet sniff. We were able to analyze packets, use Wireshark to analyze packets, and we also saw how to run a very simple tool to detect ARP attacks. I hope you enjoyed this class. Thank you very much.